Ever seen a button chase your mouse in Java Swing? In this video, we'll create a magnetic button effect, a modern hover animation where the button smoothly follows your cursor and springs back. Let's get started. First, let's create a new Java class and name it Magnetic Button. Now, at the top of our Magnetic Button class, let's add the required imports. We'll import Swing for swing components, AWT for graphics and layouts, Event for handling mouse events, Round Rectangle 2D to help us draw smooth, rounded button shapes. Magnetic Button class extends from Java JButton. Next, let's define a few variables that control the feel of our magnetic effect. Attraction radius is the area around the button where it starts reacting to the mouse. Max offset is 14, which is the maximum distance the button can shift toward the cursor. Stiffness is set to 0.8, this controls how strong the pull is. And damping is 0.82, which smooths out the motion and prevents it from overshooting too much. Now let's set up the styling for our button. We'll use arc=22 to give the button nicely rounded corners. BG color is a dark shade, red 35, green 39, blue 47, this will be the background of our button. FG color is almost white, red 235, green 235, blue 245, this will be the text color. And finally, accent is a bright sky blue, red 99, green 179, blue 237, this will give our hover glow effect. Next, we'll set up a few variables to control the glowing effect. We'll keep glow enabled set to true, so the button will show a glow when hovered. Glow layers is 7, that means we'll draw multiple soft outlines to create a smooth glow. Pulse speed is 0.12, which controls how fast the glow pulses in and out. Base glow alpha is 40, so the glow has a soft starting transparency. And pulse glow alpha is 70, giving it an extra boost of brightness during the pulse animation. Now let's add the variables that keep track of our animation. Off-X and Off-Y start at 0, these represent how far the button is visually offset from its normal position. Velocity X and Velocity Y are also 0, these store the velocity as the button moves toward the cursor. Target X and Target Y define the position the button is trying to reach. We'll use Inside Radius, set to false by default, to check whether the mouse is inside the attraction area. And finally, Phase, starting at 0. Will control the pulsing animation of the glow. Now we declare a private final timer, which will be responsible for updating the animation of our button. Then we create the magnetic button constructor, which takes in the button text. In the constructor, we'll customize the default look of the button. We call setFocusPainted method false to remove the blue focus outline, and setBorderPainted false so Swing doesn't draw the default border. Next, set Content Area Filled false and set Opaque false, let us take full control of the button's background painting. We also change the cursor to a hand cursor when hovering, and finally set a bold font with size 14, to give the text a clean, modern style. Next, we'll create a new timer that runs about 60 times per second. On each tick, it calls our tick method, which updates the button's movement and glow. We set the timer to coalesce true, So if updates ever pile up, it combines them instead of running late. Finally, we call start, so the animation begins right away. Now let's create the tick method, which runs on every timer update. First, we calculate the acceleration, that's the difference between the target position and the current offset, multiplied by the stiffness. Then we update the velocity, applying both the acceleration and the damping to smooth out the movement. Next, we add the velocity to the offset, so the button shifts toward the cursor. If the mouse is inside the attraction radius and the glow is enabled, we also increase the phase value. This drives the pulsing glow animation. Finally, we check if the button is already very close to its target and the velocity is almost zero. If so, we snap the offset exactly to the target and reset the velocity, so the button doesn't jitter. At the end, we call repaint, which redraws the button with its new position and glow. Now let's add a helper method called getCenter on screen. If the button isn't currently visible yet, we'll catch an illegal component state exception and simply return null. Inside, we use getLocation on screen to find the button's position on the screen. Then we add half of the button's width and half of its height, so we can return the exact center point of the button. This method is important, because our magnetic effect needs to know the button's center to calculate how it should move toward the mouse. Next, we'll add a small helper method called EaseOutQuad. It takes in a value t between 0 and 1, and returns a smooth version using a quadratic easing formula. This makes the motion start fast and then slow down gently as it gets closer to the target, giving our magnetic button a more natural and polished feel. Next, we'll create an AWT event listener that tracks the mouse position anywhere on the screen. First, we check that the event is actually a mouse event, and that our button is showing. If not, we just return. Then we grab the mouse's screen coordinates, and also calculate the center of our button. We find the distance between the mouse and the button's center using the Pythagorean formula. If the distance is less than or equal to the attraction radius, we set inside radius to true. That means the button should start moving toward the cursor. We then calculate the normalized direction from the button center to the mouse, and apply an easing function so the closer the mouse gets, the stronger the pull. From this we update target X and target Y, which represent where the button should move. If the mouse is outside the radius, we simply reset both target values to 0, so the button springs back to its center. Now we'll attach our global mouse listener using the toolkit. We register it for both mouse events and mouse motion events, so the button can track the cursor anywhere on the screen, not just when the mouse is directly over the button. Finally, we'll add a hierarchy listener to handle cleanup. Here we check if the button's displayability has changed. If the button is no longer displayable, for example, if the window is closed, we remove the global mouse listener from the toolkit, and stop the timer. This makes sure our program doesn't keep running background events after the button is gone. Now let's override the paint component method to draw our custom button. First, we create a new Graphics 2D object and translate it by the current offsets, so the whole button shifts toward the mouse smoothly. We also turn on anti-aliasing to keep the edges clean. Next, we grab the button's width and height, and draw a soft black shadow behind it using a rounded rectangle. Then we draw the main background shape of the button with our chosen background color. If the glow is enabled, and either the mouse is inside the attraction radius or the button is offset, we draw the pulsing glow. We calculate a pulse value using sine, then adjust the alpha to fade the glow in and out. By layering several strokes with different thicknesses and transparency, we create a smooth glowing outline around the button in the accent color. After that, we draw the button's text in the foreground color, making sure it's centered both horizontally and vertically. Finally, we dispose of the graphics object to clean up. Next, we'll override the paint border method. Here we simply leave it empty, which means the button won't draw the default swing border. Finally, let's create a quick demo to test our magnetic button. Inside the main method, we'll use Swing Utilities invoke later method to make sure everything runs safely on the event dispatch thread. We'll create a new JFrame called Magnetic Button Demo and set it to close when the window is closed. Next, we'll add a J-panel with a grid bag layout so our button stays nicely centered, and give the panel a dark background color, red 24, green 26, blue 31. Then we create a new magnetic button with the label HoverMe, and set its preferred size to 200 by 52 pixels. We add the button to the panel, set the panel as the frame's content, and finally set the frame size, center it on the screen, and make it visible. Now when we run the program, we'll see our magnetic button in action. Let's customize the style of our magnetic button. We can call Set Accent Color and use a bright neon cyan. We can increase the glow layers to 8 for a softer glow, and adjust the pulse speed to 0.15, to make the glow animation a little faster. Feel free to play around with these values to create your own unique button style. Thanks for watching. I hope you enjoyed building this magnetic button effect in Java Swing. Don't forget to like, share, and subscribe for more modern UI tutorials.